In this lecture, we're going to perform the calculations to do a two-tailed test. And we start by importing the functions that we need. And so from NumPy, I'm going to need random because I'm going to generate some random data to take a sample. I'm going to need a square root to take the square root of my sample size, an absolute value because I need this in my test criterion, the mean because I'm going to be taking the average of my sample, and the standard deviation because I'm going to take the average of my sample. And from scipy.stats I'm importing norm, but because I'm going to be using this to calculate my critical number. Now in this test, just as a change of pace, I've chosen to do a significance level of 10. Okay, and so we're only going to be wrong 10% of the time. And my mu is going to be 50. Okay, and I'm going to take a sample size of 50 as well. And I'm going to do my critical number. Okay, is calculated as going to be 1 minus the significance divided by 2, because this is a two-tailed test. Okay, so let's shift enter, and what is this critical number? If I've done it right, it should round off to 3 decimal places as 1.645, and okay, it does. I calculated it correctly. Now I am defining a function for my test statistic, my test stat. I call this variable m naught. It's a typo when I did it originally, and I should fix it down here. Okay. M naught. X bar, that's going to be where I put my sample mean standard deviation, that's where I put my sample standard deviation, and sample size, this is where I put my sample size. Now, what might bother some of you is that this sample size here, this variable, it looks like it's already been defined here. But when you have a function, this variable is in a different name, what's called a different namespace than this variable. These are all particular to this function. Okay, and within the life of this function, they'll stay the same, and have nothing whatsoever to do with this until you actually substitute these values into here. Okay. So let's see. Anyway, my standard error, okay, is the standard deviation divided by the square root of the sample size. In my test statistic, then I do my x bar minus mu naught or m naught in parentheses divided by my standard error, the mean, and that is all inside my absolute value function. Okay. My test criterion, okay, I'll have my test statistic, okay, number, my critical number, okay, and I'm going to return the value here of this Boolean binary operator, test stat greater than the critical number. So if the test statistic is greater than my critical number, okay, it'll be true. So I'm going to make myself a note here. Returns true when I should reject the null hypothesis. Okay. Okay, now, so I had set up here at the beginning, I had set my mu equal to 50. Well, why had I chosen 50? Because I want to check whether this random dot uniform here, if its mean is actually what it should be. Its mean should be 0 plus 100 divided by 2. So the random uniform between 0 and 100 should have a mean of 50. Okay, but so I'm going to actually sample it and see if that is actually right. So I let x bar be the mean of this sample and st DVE be the standard deviation of this sample. So I had those calculated. I then use my test stat function to calculate my test statistic. Okay, get its TS. Okay, then I use my test criterion. I put my TS in where the test statistic should go. I put my critical number in where the place where critical number is. So this critical number, oddly enough, is this critical number back here. Okay, and it's just in the same placeholder as this critical number. Okay, so shift enter there, and so false. Okay, so I should not reject this. That means that my null hypothesis in this case, which is that mu is equal to 50, I cannot reject it. Okay, now, so right now, at this point I would be done with my hypothesis test. Now, I want to show you though, so you have a better concrete idea of what's going on. I took the sample. What is my sample? Well, my sample is these 50 numbers right here that I chose from the interval 0 to 100 in a uniform fashion. My actual x bar was 48.84 junk. Okay, the standard deviation of that was like 30. Wow, big standard deviation. But when I calculated my test statistic, it was like 0.269, so it was pretty small. And so the standard error of it. Oh, and here, so what have I done? Well, let me show you. Okay, I meant to do that. Okay, to illustrate that whereas I do have standard error defined up here. Okay, it is in the namespace associated with this function. So it's only defined inside the function. Okay, and I type it here outside, even though it's past that point at the notebook. It has no meaning outside the notebook. It's still stuck up inside that function. So anyway, there you go.